AMD recently released a new version of their Ryzen Master software that has an auto curve optimizer on it for their curve optimizer feature. And I thought it was a good time to go through and answer, what is curve optimizer, how does it work, and how can you benefit from it? Let's take a look. So with the latest version of Ryzen Master, when you first open it up, you can actually see that there's a new button here called Curve Optimizer. So if we click on that, it gives you the option to choose Curve Optimizer mode off, all cores, or per core. And we'll get into that a little more detail later on. Now when you first set up your Curve Optimizer profile, there's going to be, instead of a Validate Offset button here, you're going to see an Optimize button. And that button will allow you to run basically a test that the AMD Ryzen Master is going to try to automatically calculate what the best offset is capable for your CPU. Now, the unfortunate thing is that when I ran this, AMD Ryzen Master said all your cores will run perfectly fine at a -30 offset. And the challenge is that's not really true. But to understand that, we really have to understand what we're doing to the curve and what Curve Optimizer is actually doing, and why there may be some stability issues, even though Ryzen Master says it'll run fine at the highest possible offset. So when I ran Ryzen Master, it gave me this right here. So it said, below are the curve optimized values. It has been optimized. So Curve Optimizer per core, and it said that the optimal was -30 on each core. So here's the challenge. Technically, my CPU will run at load at a -30 offset and be, for the most part, stable. The challenge isn't necessarily at the peak of the curve, the challenge is at the bottom of the curve. So to illustrate this, I'm going to use Excel. And imagine, if you will, that this curve, this green line, is your curve that we're optimizing. And your voltages are, say, here at 1.4 volts or here at 0.2 volts. The way the curve is set up is we can optimize it by adjusting where on the voltage line that curve is going to be by adjusting at about 0.06 millivolts per increment. So a negative offset of 1 is 0.06 millivolts less. We can see based on my diagram that based on peak voltage, which is 1.4 to 1.5 volts, we're going to cap out about 4.4 gigahertz or 4.5 gigahertz. So what happens if I apply a positive offset? Well, that moves the curve along the voltage line on the positive side. So that gives me now 4,000 megahertz at 1.4 volts. Now, if we go the other way, if we do a negative offset on the curve, we actually move the curve to the left. So you can see if we are able to offset the curve far enough, our peak boost at peak voltage is going to be 5 gigahertz. And this does work in theory. At -28 offset, my 5950X hits 5 gigahertz consistently. So when we're talking about your average boost speeds, it will hit an average boost speed of 5 gigahertz, no problem. Now the problem is this. We may be moving this along the curve, but look what happens at 0.06 volts. So now if you see I move the curve to the left at 0.06 volts, we're actually now running at 2 gigahertz. Now this chart is a representation of the curve. I don't know what the exact curve settings are that AMD has built into the CPU, but when I look at where the stability issues can come in, it's actually in the lower range of your megahertz. So sure, at peak load, my CPU no problem will run 5 gigahertz, but I run into stability issues when the clock speeds are lower, or when they're lower down in the voltage range, because now there is not sufficient voltage to actually maintain the clock speeds required at the lower clock speed levels. Now the challenge here is that Ryzen Master doesn't really test for this, and to be frank, it's really hard to catch. For example, when you're playing a video game, the settings that you're using might be stable for 2 or 3 hours, but your system still locks up or reboots, and there's something I really want to mention when it comes to your builds. No build should ever have instability. Yeah, there's sometimes driver issues and sometimes there's some issues with certain software programs, but for the most part, your system should be stable. It shouldn't be crashing once a day or twice a day. Games shouldn't be causing it to overload or to stop working properly. There's usually a hardware reason for that, bar some major issues with software. So that being said, if your curve optimizer runs perfectly well with a -30 offset for 2-3 hours, but then it reboots. You don't want that to be happening during, say, a disk defragment when it's moving data from one part of the disk to the other. You could lose some data that way. You also don't want that to happen when you're working on or rendering a project, like a video that you're editing, because those are going to cause errors and issues with whatever you're encoding, whatever you're creating, or you might lose time and progress or lose work altogether. So now I want to take you into the BIOS. And I want to look at the curve optimizer settings and kind of show you some of the ideal settings that you could use and talk a little bit about stability testing, show you some of the gains that you can get. So here we are in the BIOS of the ASUS Crosshair 8 Dark Hero X570 motherboard. And depending on the motherboard you're running, you'll just want to look for your AMD overclocking options. And under AMD overclocking, you're going to have the Precision Boost Overdrive option. That's where we're headed. Now, you'll see I've already got some things tweaked and dialed in for my day-to-day use, which is just a mild overclock by releasing the power limits. But we're interested in going down into Curve Optimizer today. So with Curve Optimizer, you can change your settings either auto, all cores, or per core. Now, all cores will work for the most part, but to really dial it in, going per core may give you some better options. And it depends how much time you want to spend doing this. If you want to spend weeks doing this, then per core is going to be great. If you just want a really quick win, all cores is awesome. You can go all cores -9 or -5 and usually get decent results. So again, what we're doing is we're moving the curve for the clock speed and the voltage either negative, or moving the curve kind of to the left in the graph that I showed, or positive, or moving it to the right. And for the most part, I don't see any major use for making a positive adjustment, because you're going to get the most gains out of a negative adjustment. A positive adjustment might come in if you're having instability on default on stock clocks, but that shouldn't even be an issue. So if you're first starting out, I would recommend starting at a -5 and then running some stability tests, and then work your way down. I find that a -15 on my 5950X was too high and it would actually crash. So on most of the cores, they're only good to about a -14. I found that on the second CCX on the processor, most of the cores can only do a -9. So depending on your cores, when you're looking at your AMD Ryzen software, you'll see that it has the starred, kind of the preferred cores. If we go to per core, we can see that what I've done here is my preferred cores, so core 7, which is actually, because these start at 0, that'll actually show up as core 8 depending on what software you're looking at. But my 7th core, starting at 0, the 20 is actually the best negative offset that I've been able to use so far. Now, I was using 28, and I was stable for about 2 or 3 hours at a time, but then the computer would black screen and reboot. So I moved up to 25 and then tested it again, played some games, day-to-day normal use, and it crashed. So I will mention that I've turned off drive defrag, and I've done that because I don't want there to be instability when I'm moving data around. So -20 is about as good as this is going to get for my particular system, and I haven't run into any stability issues yet. But when I look at some of my other optimized curves, for example, my core 9 can only go to -13. And I've done -14 on my first 8 cores, or my first 7 cores starting at 0. So I found that I could run -14 on each one of these cores. And I've done this by testing, trying each core one at a time. You know, can this one do 15? Do I run into some stability issues? Then turn it to 14. But the thing is, doing that, I can only make one change at a time and then go to day-to-day use for about a week to see if there's any issues. If you go and you change all these to 15, you don't know which core is unstable. So you kind of have to do them one at a time. This is a grossly time-consuming process to dial everything in. But I do know that setting each core to -14 on CCX1 has been stable consistently for the last couple of days, and setting all of my regular cores on CCX2, so core 8 through core 15, setting those to -11 has been good as well. So my core 9, I have -13 because that's one of my preferred cores. And then core 15 is actually a preferred core as well, so I'm running that at -13. And I might, again, a week from now, I might come in here and say, you know what, let's run it at 14 and see if that's going to be stable. But again, I can't go changing each of these one at a time and then just run a benchmark, because a benchmark is going to just use full load. And again, I know all of these cores are stable at a -22 to -25 at a full load. The stability issues don't even kick in until you get down into the lower frequencies, or when you have your CPU cores changing from their sleep state to a very light load condition. Remember, they only boost up to high boost at certain loads. If there's just a small load, then they just kind of go a little bit in between their boost ranges. So setting every one of these up is going to take a lot of time. So someone who's new to this might just want to go all cores, -10, and try that. Run that for a week. Play games, run some benchmarks to be sure, but make sure that your temperatures are good and just see kind of what kind of results you're getting out of your CPU clock speeds and stability. So what do some of the specific changes do on here? Well, let me show you some of the results. We'll get back to the operating system and I can show you there. So back in Ryzen Master, I just want to point out your preferred cores again for those who are new to this. If you look at my different cores, you've got your CCD0 and your CCD1. And if you look at the individual core, there's core 0, 1, and this core is actually core 0 in the BIOS. So here we can see that core 2, core 8, core 10, and core 16 are actually my preferred cores. The ones with the gold stars, those are the best ones. The ones with the little white dots, those are your second best core on that CCD. So here we can see the clock speeds are fluctuating. So for example, core 2 is only running at 2000 megahertz right now. So that's going to be running less on the curve at 2000 megahertz than it would say at a higher load. So that again is where we get our instability. So if we look at core 8, core 8 is where we get a lot of our preferred processing. So if I go ahead and run Cinebench on a single core run, we'll see that the cores that it's preferring to use are going to be core 2 and core 8. So we can also go into our task manager and we can go to Cinebench before we do a run. So if I go to Cinebench here, I say stop. I can go to Cinebench and I can say, go to details. Then I can go down to Cinebench and I can go set affinity. So again, these aren't physical CPUs, these are now logical CPUs. So for example, if I'm starting 0, 1, that's going to be core 1. 2 and 3 is core 2. So if I want core 8, I'm going to have to go down to, so if I set my affinity to cores 14 and 15, then we go to single core CPU run, we can actually see in Ryzen Master which CPU is being utilized the highest. It's not listening, and that's because it changes its affinity every time it does a run. So I can go 14, 15, okay. And so I've now forced Cinebench to use core 8. So the two logical cores on core 8. So that's now hitting 4.8, 4.9, which is great. These CPUs are supposed to boost up to 4.9. That's pretty normal. But I'm actually seeing consistent average sustained boost at 4.9, which is actually really good. The maximum is not what you care about when it comes to your clock speeds. It's your sustained boost that actually is going to get you from point A to point B. If your CPU is jumping up to 5 gigahertz, but it's only jumping up there for a millisecond, it's not really helping you. It's not really benefiting you. But if you can get 5 gigahertz sustained boost, well, that's awesome. All right, so let's stop Cinebench. And I want to kind of walk you through some of the results that I got. So for example, this is a stock run. Zoom in on that. I know this is so high tech, but so for my stock run, I was using core 1, which is actually my core 2. So if we look at Core Optimizer, core 2 is my kind of ideal, secondary ideal core. So I was running it on core 1. Core 1 was averaging about 4.729 megahertz sustained boost, with a peak of about 4.825. And that's just stock. That's with stock settings, with some of the power limits released on the Precision Boost Overdrive. 4.7 is a long shot from 4.9. So I went in and I did an all-core -9. So an all-core -9 offset got me up to a sustained boost of 4.817 on my core 1. And you can see that the current reading was 4.8. and the maximum was 4875, which was actually a little bit higher. So a -9 offset helped a little bit. So now I decided to do a -14 offset. During a Cinebench run at an offset of -14, Core 1 was able to get an average sustained boost clock speed of almost 4.9, with a peak of 4.977, and you can see the current at the time of the screenshot was 4927. So that's a lot better at -14. So you think, okay, well, Ryzen Master told me I could do -30, so let's keep going. So to keep going, I wanted to focus primarily on Core 7. So this is actually Core 8 in Ryzen Master. That's my top best performing core on the entire CPU because it's on CCX1, because it has a gold star. So if I look at my Core 7 at a -14 offset was getting a sustained boost at 4.937 gigahertz. And I was doing a max of 4.952. Okay, -14, we can go further. So I went to a -20 offset. So -20 offset with Core 7 was sustaining an average boost speed of 4.95 gigahertz with a peak of 4.975. Ryzen Master says I can go further, I go further. So we went to -28. So at a -28 offset, you can see Core 7 is at 5 gigahertz. And it actually sat at 5 gigahertz a lot. And the only reason it really fluctuated below 5 gigahertz is because of change in load, switching between each image that's being rendered in Cinebench. So I actually had a sustained peak boost of 4.971 gigahertz. And pretty consistently it was running at 5 gigahertz at most times. Now this ran stable for 2-3 hours doing normal tasks, playing games, until it didn't. And then it crashed, black screened, rebooted the computer, and I lost the session that I was in and I had to start over. Luckily, the game I was playing had an autosave, so I was okay. But you have to be careful because, again, I could run Cinebench all day long at -30 offset on all my cores and it'll be stable. It won't crash and it won't blue screen. But the second I go to play other games, it'll start to crash. And actually at a -30 offset, it crashes in almost every program that I try to run. And it doesn't always black screen and it doesn't always reboot, but there's no stability. The stability is weird. And even at -28, on just Core 7, I was still having some weird issues, like programs were taking longer to load than they should. Applications were kind of lagging or acting funny. My file explorer seemed really delayed. And all of that stability was actually coming from having too high of a negative offset on Core 7. So when you're using Curve Optimizer, you have to be careful. If you go too far, you may not have stability issues running benchmarks or heavy workloads, but when you start playing games or using applications that fluctuate workloads from heavy workloads to light workloads and sleep mode on the individual cores, you're going to run into stability issues that'll cause your system to just go haywire and act really weird. So I would start with a very light negative core offset. Maybe start with -5 and go from there. And you can do that in Ryzen Master. So you can go to your Curve Optimizer, and once you've done your optimization, which takes about an hour or two, depending on your CPU, you can go in and you can type in the core values that you want. So you could say all core, you know what, I want all core -5, or an all core -10. To be honest, you're probably going to be stable at an all core -10 with most systems. But I've seen some CPUs that get unstable doing any kind of a negative offset on them, or anything below a -5. It's also going to depend on the motherboard you're using, the power delivery, and a number of other factors that I can't really write a formula for. But that being said, start with maybe a -10 and give it a try. You can hit validate offset, and Ryzen Master is going to sit there and calculate and make sure that it works. All Ryzen Master seems to be doing is just putting a load on the CPU to make sure that it's stable. But what Ryzen Master is really missing is when there's instability at lower loads, at lower clock speeds, when there just is not sufficient voltage based on where we've positioned that curve to keep the system stable. So there's a lot more detail I could go into with overclocking, and I'm trying to do short videos touching on different aspects of overclocking where it might be of advantage to someone who's just starting out. If you're looking at tweaking your CPU using Curve Optimizer, I hope that this has given you enough information to get started. That's the end of the video. I hope you found it useful, and I hope I'll see you again. Thanks for watching.